Hi everyone, welcome back to my channel. In this video, we will derive the following identity: 2 choose 2 plus 3 choose 2 plus up to n choose 2 is equal to n plus 1 choose 3. We will prove this by using mathematical induction. So by using mathematical induction, we will prove the following identity. So first, let us denote this statement by Pn. So denote it by P of n. So we need to prove P of n is true for every n greater or equal to 2. Okay, so now we will try to prove the initial case. So the initial case will be for n equal to 2, since the first term is 2 choose 2. Okay, so for n equal to 2, the LHS is 2 choose 2, which is 1. And what is RHS? RHS is 2 plus 1 choose 3, which is nothing but 3 choose 3, which is again 1. So LHS is equal to RHS for the n equal to 2 case. So that will imply P of 2 is true. Now we will assume P of n is true. So let us assume P of n is true. So what is P of n? It is 2 choose 2 up to n choose 2 is equal to n plus 1 choose 3. Okay. Now we need to prove. So what we need to prove? We need to prove P of n plus 1 is also 2. So what is P of n plus 1? It is 2 choose 2 plus 3 choose 2 up to n plus 1 term, which is n plus 1 choose 2 is equal to. So we'll put n plus 1 instead of n in the right hand side. So it will be n plus 1 choose 3, which is nothing but n plus 2 choose 3. Okay. So let us write the left hand side of P of n plus 1. So P of n plus 1, the left hand side of P of n plus 1 is 2 choose 2 plus 3 choose 2 up to n plus 1 choose 2. Okay, so rewrite this as 2 choose 2 plus 3 choose 2 up to n choose 2 plus n plus 1 choose 2. Now, by the induction formula, we know that this is nothing but Pn. So we know that Pn is true. So this sum will be n plus 1 choose 3. So this is nothing but n plus 1 choose 3. And the second term is, and the last term is here, n plus 1 choose 2. Okay. So now let us calculate this. So it is n plus 1 factorial by 3 factorial into n plus 1 minus 3 factorial plus, again we have n plus 1 factorial, 2 factorial into n plus 1 minus 2 factorial. So it will be n plus 1 factorial by 3 factorial into n minus 2 factorial plus n plus 1 factorial by 2 factorial into n minus 1 factorial. Okay, so the first one you can write it as n plus 1 factorial and 3 factorial as 3 into 2 factorial. And we have here n minus 2 factorial. The second term we will rewrite as n plus 1 factorial by 2 factorial into, so n minus 1 factorial is n minus 1 into n minus 2 factorial. Since we know that this n factorial is equal to n times n minus 1 factorial. Okay, so now what is the LCM of the denominators? So it will be 3 into n minus 1 into n minus 2 factorial into 2 factorial. And what will be the numerator? The numerator will be n plus 1 factorial into, note that here we have 3 2 factorial into n minus 2 factorial. So here we have only n minus 1 is missing. So n minus 1 plus here n plus 1 factorial into 2 factorial into n minus 1 into n minus 2 factorial. So into 3. So now take common n plus 1 factorial from numerator. So n plus 1 factorial into n minus 1 plus 3. And the denominator we can write it as 3 into 2 factorial and n minus 1 into n minus 2 factorial. So we have n plus 1 factorial into n plus 2, and we have 3 into 2 factorial is 3 factorial, n minus 1 into n minus 2 factorial is n minus 1 factorial. And in the numerator, n plus 1 factorial into n plus 2 is equal to n plus 2 factorial. So we have n plus 2 factorial by 3 factorial into n minus 1 factorial. Okay, so then we can rewrite it as n plus 2 factorial by 3 factorial into, so n minus 1 we can write it as n plus 2 minus 3. So it is nothing but n plus 2 choose 3, which is the RHS of the Pn plus 1. So exactly we get P of n plus 1 is 2. So now so far what we have got. So first we show that P of 2 is 2. Then by assuming Pn is 2, we prove that P of n plus 1 is 2. So by mathematical induction, we prove that P of n is 2. So we are done.